First of all, it's slower than usual. Okay. Short today. Well, text is short today. What happened yesterday is that we got extremely confused. We confused ourselves for the longest time, and then what worked as usual was to just kick back, burn it down, start from scratch. Module main where, main IO main equals return. Let's do the preliminaries. Language is G21. Import util. Okay, that's how we start. Now, let's see what we're doing now. You and the elephants finally reach fresh air. You emerge near the base of a large volcano. Oh no. Oh, volcanoes are my specialty. Fortunately, the lava seems to be flowing away from you and toward the ocean. Bits of lava are still being ejected towards you, so you're sheltering in a cavern acting a little longer. Outside the cave, you can see the lava landing in a pond and hear loud hissing as it solidifies. Huh, obsidian. Okay. Speedy which is cool is it might be forming obsidian. Yeah, we call this raptina. They're like ravens, a flint in Iceland. The cooling rate should be based on the surface area of the lava droplet, so you take a quick scan of the droplet as it flies past you. You personally, because of how quickly the lava is moving, your scan isn't very good. Its resolution is quite low, and as a result, it approximates the shape of the lava droplet with 1x1 cubes on the 3D grid, given as its XY Z positions. Ding. So if you okay, count the number of sides of each cube that are not immediately connected to another cube. Ding. Let's get the. I'm gonna code is slow today. I don't know why. Paste the input here. Oh wow. So if you scan where only two. Okay. So these are the coordinates of the cubes. Count the number of sides of each cube that are not immediately connected to another cube. So if your scan were only two adjacent cubes like 111 and 211, each cube would have a single side covered and 5 sides exposed. A total surface area of 10 sides. Okay. Ding, 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 ding. Okay, let's say, look at this. Single side 5 sides equal to surface at 10 sides. Okay, we have got some collision code from yesterday though. That's good. Let's see. Read input. We're not gonna bother with input today. We're just gonna say a file path to IO crypts int. Read input equals fmap lines dot read file dating slash example. Now L2 C. Let's just write it. Data input int comma int. Okay, let me actually int. Now I want to say C I to C is equal to I x equals x. I to C map I to C dot reads. Right. Instance read input where reads prec equals parse prec parse, where parse equals a step by read. So this is going to be read as to p reads, and this is going to be jar comma. And this is going to be set by ding 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 do XYZ. Return XYZ. Read S to P. Okay, we got the chords. Do read input dating example. Let's run it. Boom, we got the chords. So 1x1 cubes on a grid. Okay, let me actually now oh my god, import qualified data.int map, import data.int set as import a qualified data.int set as is. Now how do we construct? So we got a list of coordinates. Let's construct all the sets in to set. To int cubes to cubes to set xyz equals im dot singleton x im dot singleton y is dot singleton z. Cube union cube to cube to cube. So cube union equals a union im dot union width okay, so here we have the two, and then this one is im dot union width, and then is dot union. Okay, now let's task one. Let's take the int comma int comma int, and let's view the cube in this way. Task one equals task one equals map to set. We're gonna do fold a cube union, and it's gonna start off on the empty cube. Ding 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 ding. So these are the ones and the twos, and then the 2 and 5. sides. This is gonna be the hard function cube to int. Now let's say a tiny example equals now let's print the tiny example. Now I want to say rotate. Okay. Rotate cube to cube. How do we rotate the cube? Rotate equals cube equals, okay. Let's do im.shocks. Okay, let's see what happens if we print. Oh, we're not rotating anything yet. Okay. Well, let's make this into a list. So this is a list of ints, and This is the target type. Currently, now I'm gonna go to the map. X comma map. X comma Y's. Zip, repeat, X. Okay, so now we have these. No, I want to say okay, and then dot here. Okay, so we go here, we go this is gonna be a X comma okay, so why can I not do this? Maybe because it's not list yet. Okay, yes, and then next Y and Z. Repeat X. Repeat X. Okay. Okay, so we covered the ones and twos. I'm getting a bit of a deja vu here. I feel like we've done something like this before, but okay. Does this work for the example? Input? Yeah, it seems like it. Map X, Y, Z. Okay, we've recovered all the... Now let's rotate it. Okay. Map is so X, Y, Z. Z, X, Y. So let's print a tiny example. We print rotate tiny example, and we print rotate tiny example. And so, and then we can see that one of them has 2. And let's see. So there's 1, 2, 3, 4, 5. And if we rotate it one more time, we should get the original bit. Yeah. So here we can see that one of them is joint, right? Ding, 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 ding. Those sides cube equals a count is equal to im dot fold L I want to take the current number of sides and for that chord v to c plus im dot size v. Now I want to do this for the cube equals a count a cube plus count rotate cube count rotate let's say r cube equals rotate cube r cube equals rotate r cube. So we're gonna do sum dot sum map count cube r cube r cube. Okay, and here I delete this one. Then we call a print $sides tiny example. This should give 5. Print okay, so there's a 10, but for this one there are 25. So it's not just this times 2. The print let's see, cube is a 2 cube over read input. Print cube, print rotate cube, print rotate. So here we can, from this we can at least read what is let's just not do it all of them. Let's just do joined tiny example. Print join. Let's see. Print EX. So there's a 13 in here. Let's see, so one cube has 8 sides. Point cubes. Make constituent cubes. Oh. And let's see. Now let's print Okay, so 13. 8 times, a cube does not have, cube has 6 faces. I am a mathematician, don't worry. So for the other one, that's gonna be so here we have 10 different sides and 10 different sides and 5, but there we have only 5 different sides. Do 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 do. So what if I do a size of a cube, so 2 times rotate the RC equals rotate map joined map joined CRC RRC. But it might not be contiguous, right? Like here we have 1, 2, 3, 4, 6, right? Let's check this joined here, where S join. Okay. S join takes in a set. Okay. Equals is dot from list s. So equals where? So how do we will join Google. Let's see, group by. Import a data list. Group by compare on a div2. Links. Ah. Okay, x and y are equal if x plus x equals y or x plus 1 equals y. S dot to list s. Let's see this. Okay, import data. I want to say here. So okay, so 1, 2, 3, 4, 6, 7, 8, 10, 12, 13. Oh, okay. Now group by import data dot function. Okay, and then group by equals on div 2. Oh, this is not correct. X, Y, x plus 1 equals y. It's just like x, x, y, x plus 1 equals y. X plus 1 equals y. So I want to merge all those so that are continuous. Okay, let's write it in a different way. contiguous. Int, so list of ints to a list of ints. Contiguous, empty equals empty. Contiguous, x, y, r equals, okay, so if x plus 1 equals y, if this is the case, then it's actually we'll do x okay, what are we doing here? Okay, so here here they are contiguous, then we'll do let r rc rest equals a contiguous yr in a xrc added to rest. Then this is not the case. Contiguous xyr otherwise equals x contiguous yr contiguous x equals x. GI day 18 reaches. Just join. Let me get the L again, and then contiguous L. Okay, so these are the contiguous numbers. Okay, and so we're gonna do fold L again. Fold L now. Here we have the insets. C and the is C plus length contiguous is dot from list, not is dot to list is 0. We're getting 32, and we're getting 5. Oh my god, nice. Sides is 2 times this. Sweet. Okay, let's see if that works for the input. Task 1 is int 2 int. Task 1 equals sides dot to cube. Day 1 print dot task 1. Let's make a tiny example here also. Actually, new file. Example. $3,500. Does that work? All right, we got task 1. And I feel like we did it in a very nice way. It's very fast, 23 milliseconds. Now, part 2. This is where it gets hard. The cooling depends on the exterior surface area, but your calculation also includes the surface area of air pockets trapped inside the lava droplets. Instead, consider only cube sides that could be reached by the water and stream as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. Exactly 1 cube of air is trapped within the lava droplet. Oh my god, okay. This is a lot harder. Let's see. But I feel like we did task 1 quite fast. Let me see the stats. Oh, we were in the top 15k. Not bad. Okay. So here I feel like we should compute like the interior cubes and calculate those areas, and then calculate the and deduct that from the total area. Okay, let's see. Let's write here gaps. Gaps. Okay, so we're gonna write is I am dot foldout to the current gaps and a key current plus dim. Okay, and then gaps prime dim, and then we go to the end list where gaps prime dim I am dot foldout is a gaps prime is so gaps prime takes in the is. Gaps prime takes in int set. Folder with key C key gaps K and this is K prime Okay, so I want to take all of these and I'm gonna say zip repeat key prime dollar. Okay, and then this is gonna be zip repeat k. Okay, and the gap here is where m is min is equals int z is dot find min max is equals is dot find max. Max is find the is, and then we're gonna just say filter is dot member is not lib is member is min is 2 max is. So let's print here a read input the 18 example print gaps dot print dot gaps dot to cube. One, two, two, and 5. 1, 2, 3 is not there, and 1, 2, 4 is not there. Okay. So here we have 2. So 2, 2. 2, 1 from list, 2 from list, 1, 2, 3, 4, 5. 3, 2, 5. And 3. So let's print this differently. Map m dot sox. So my question is There's something going on here. Okay, let me just send gaps X in here. X. I'm not gonna do this part. Gaps X equal full key Y. Gaps X Y. Gaps X Y IS. Map X comma Y comma. Show ID. One, two, and then the 1, 2, and 3, and 1, 2, and 4. So 1, 2, 3 is not there, 4 is not there. Okay. Then 2. 2, 3, and 2, 4 is not there. So why aren't we getting the 2, 2, and the... Trace show X, Y. I got the 225 there for sure. Now how can I tell that one of these is completely contained in the cube? Because it might be at like the center, right? Well, if it's... Right. Maybe something is contained. Okay. Let's say neighbors. Int, comma int, comma int. Int, comma int, comma int. Neighbors equal. It never expands diagonally, so we're gonna do a x, y, z equals, so it's gonna be x plus 1, a, y, z. X comma y plus 1 comma z. X comma y comma z plus 1. Then x minus 1 y z x comma y minus 1 comma z x comma y comma z minus 1. Okay, now we're gonna write a contains function, so we're gonna say contains. And we're gonna take a int, comma int, comma int, and we're gonna take a cube. And we're gonna say contains x, y, z is equal to do just y s is gonna be c. Flip this. Cube int 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 c x y z just y equals a I am c I am dot bang x is just $do just says c I am y's I am dot y, and then okay, I'll do it like this. Just y's, just z's, sets set dot member z Okay, so now I'm gonna write this function here. So task 2 equals to, so this is the, okay, so task 2 equals fint equals where c equals 2 cube int. Okay, now g's, all g's equals gaps cube. Now I'm gonna filter all GS by saying G. Okay, and now we're gonna say GS cube equals 2 cube all GS. Now filter, so G A E E do. Then I'm gonna say all contains C all, okay, and then the G, so the gap is within the cube if all of its neighbors are either in the cube or also a gap. All, and then a check a neighbors G. And then check here takes in a neighbor and it checks that a contains a cube contains a neighbor, or the gaps cube contains GS cube neighbor. Let's see here, print task 2. And those are the gaps. Okay, so actual gaps equals actual gaps. We're gonna make a cube out of that. Actual gap cube equals 2 cube actual gaps. Now, how many sides? So what is it? So we're gonna do. The result here is a sides of C minus sides of actual gap cube. $58. What do I get for the input? 2018. Your answer is too low. It's the right answer for someone else. Oh. Okay, but we're definitely not far off. But it's a bit annoying that we get the correct answer for the Very annoying actually. Let me write here. The answer was too low, which means that we're overcounting something. I was ready to get. I feel like these gaps could be many different cubes. Let's see. I'm gonna check one thing today. Give me 1 second here. Just gonna move some chess pieces around. Just gonna move one around actually. I'll do the other ones later. Let's see. So we get the gaps. Okay, let's see here. Let's change the gaps, but only the actual sides. Let's see, actual gaps. We're doing it for the example. Okay, so these are all the ones that are right next to a so they're not in a gap, like they're actually right next to one of the cubes. This may be it. That's it. This is too high, yes. Okay, so here we have the gaps. So these all contain a neighbor. Let's see, so these are the actual gaps. And how many neighbors do they have? Wait. These are the ones that are entirely contained. 6 times, maybe it's just like that. Length actual gaps. Okay, no, that was yeah, that was exactly the one I tried. That's too high. Okay, 3284 is too high, and 2018 is too low. Too low. Too high. Editing. Let's what is the GS length of actual gaps? So these are any one of their neighbors is okay. Now I'm gonna do here how many other neighbors do actually, so map G, so sum map G filter any check neighbors G filter check filter check neighbors G length. And see here sides C minus. This is even lower, right? Yeah. These are not just the ones. Check only n equals contain. Check the only. Let me see. Okay, so here are the so these are the neighbors that are completely contained. All check. See ya. So these are side C. Okay. We'll print that out. 6. I'll say mono gaps. The length and mono gaps. Let's do a NM gaps. Partition. Yeah. Length non-mono NM gaps. The non-mono gaps. Okay, so there's okay, so it's definitely so you're definitely contained within the cube. On all edges, you can never leave without escaping the cube. Okay, so then let's just do let's just brute force this, okay? To cube in. Let's just say min x equals minimum xyz x. Minimum oh yeah, dollar map mini min z. Let's just see what these are. And we could do this faster, but max x minimum. Okay, this is maximum. Max x. So what are the ranges here? 1 to 19, 0 to 19, 0 to 19. Ah, that's not too bad. Okay, so we have the gaps. So it's gonna be one of the gaps, okay? So then we're gonna say fully contained x y z equals any contains c so they have to be, and then map any contains c of a we'll do it for the 3 any contains c and this is gonna be dot oh my god. So where x range is equal to a map I to x plus I. No, I'm not gonna do x plus I. I'm just gonna do I comma y z. So it has to be in both directions. Okay. X range is equal to max x minus min x. A y range equals a max y minus min y, and c range equals max z minus min z. We're gonna say here x range, y range, z range. The fully contained where x is x right is equal to map I x plus y I y z 0 up to no 1 up to x range. X left is equal to map I x minus y comma z 1 to x range. Okay, and I copy it and I say x and y. Okay, I just do y I range Fully contained is equal to XYZ is equal to any contains C map X right, X left, Y right, Y left, Z right, Z left, and how to do and of all of these. Okay, now let's see. The ones that are fully contained are gonna be a fully contained cube equals 2 cube of filter fully contained all GS. Side C minus sides fully contained fully contained. $2024? Could it be? Is it true? Damn it. Ding, 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 dong. Ding, 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 ding. Okay, XYZ, XYZ. So the ranges are correct. What did it say when you said 2024? It said something about... okay, 2018. 2018 was... oh, I have to wait 2024. Okay. Um, 2024 too low. all points. So this is gonna be a... all XY points. Oh no, let's this is all YZ points. All XI. Maybe the gaps function is wrong. Let's see. This should take a while. No. Oh, okay, these are even more points. Length, all XYZ. Min Y to min X Y. Min Z to Z, and then min X to max X. So we have 7,600 points. Ling fully contained $22,292 of which are fully contained within the cube. Now, okay, so these are the ones that are fully contained. How many of them have neighbors directly adjacent? So, fully contained points equals filter fully contained XYZ. Okay, now for each of them, I'm just gonna say map as sum. We're gonna take a point. We're gonna say Some filter contains C. Neighbors G. So these are fully contained points. I can't just sum the lengths like this because they might have the same neighbor, right? Set dot from list. Import data dot set qualified data dot set set, and then okay, and then set dot union. These are fully contained points. Now we want to filter. We want to filter the ones that are not in the cube as well, right? Filter, okay, and then filter not okay, and then sides C minus oh, we still get 2024. That was definitely not the answer. Okay, so wait, so these are the full okay, these are the fully contained points. Okay, now let's do the now let's do the length, the sum of how many sides it each touch. G length filter contain C neighbors of G. $20.29. That seems like a reasonable number. Let's just let's see what happens. Oh my god. $20.29 too low. So the exterior sides are, there's C. What if I do it the other way around? Okay, so I have the fully contained points. Okay, so let's write here a FC cube equals 2 cube fully contained points. Okay, so I'm gonna do this neighbor filtering, but I'm gonna do it on the filter, and it's gonna be all X, Y, Z. But I'm gonna do it on the points that filter G, P. So these are the points which are not contains C, E. They're not in the cube, and they're not contains FC cube P. So if I do this, right, this should also give me 3,500, I feel, if my calculations are correct. This gives us 3,460. I mean, maybe I screwed up this. Okay, this gives all the points. Now I'm gonna remove the ones that are not fully contained. I still get 2029, which and I feel like it's pretty weird that it works for calculating the total sides. And I was right. There's right. This is fully contained. Now let's just write the opposite function. Okay, not contained. Not contained. 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 Not contained. X, Y, Z. The Q fully contained points. What about the not contained points. And then we do a filter not fully contained. Let's see, length fully contained points. Length int and length not contained points and length and then some map length fully contained points int and not contained. So then we have the ones that are fully contained, we have the ones that are the length of the input, and then we have the ones that are not contained, and they seem to sum up to the whole space. Okay, which is good. Now, let's see if we can filter the ones map. So not the length. Filter any contains C. So these are the neighbors that are not contained. Let's see. Oh, good. I still keep getting this 2029 number, which is not correct. We guessed that already. Ding 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 ding. Okay, let me take a quick break. I'll be right back. Okay. Let me see. Sorry, I got a transition. Mizard X. Yes, I know. Listen, these are the points that are not contained within the ball. And these are the fully contained points. Okay. So I know exactly, I know exactly the area, I know exactly the points that are not contained, right? And then I count how many neighbors. Okay, maybe neighbors here should include. So how many of those neighbors, so I count, right? So how many of the neighbors of that point touch the cube, right? So that should be the face, right? So if you have one here and then you touch, you need to count the face on the outside and not counting anything inside the ball. Yeah, I mean, I know that, right? So I know exactly what is not inside, not contained, right? So then you can go anywhere and it's not within the ball. And I know exactly the ones that are fully contained within the ball. So this just checks, right, that all of them, right, if I start anywhere and I go in all directions, I hit the ball. And those are the ones that are fully contained, right? Yeah, the input forms of hollow sphere. Exactly. So a point is in the sphere, right? It's not like, okay, anyway. You think about it like this, right? I mean, so it is a hollow sphere, right? Right, just one sphere, but it could be like a outcropping, right? So these are the points that are fully contained within the sphere, right? So, you have a point within the sphere, and that's the definition, right, of a sphere, right? Like being contained, right? Like if you go in any direction, you will hit the sphere. And that's what this checks, right? That going in all these directions, x, y, x left, x right, I see right, okay? You hit the sphere. And then I can count the... And it even... Okay, yeah, right. So not contained points. Mm-hmm. And that's I mean, that's my problem, right? So this expression here, right? So that counts the neighbors. So how many points like it touches the sphere from the inside and the outside, right? And you know, as it makes sense, if we sum these two up, right, then they result in the total surface area of the sphere. Okay, but then these, so the first one here should be the exterior, and this one should be the interior. But it's saying that it's not correct. So I don't get. You could technically have a cube that has other cubes in all direction, but can still get outside via some curving tunnel. Ah, okay. Then I just okay. Then we can't do it this way. Then I need to do a breadth first search. Let's dig that up then. Did I cleverly put that in util? BFS. Let's put that in utils. Import int map. Import data.int map as qualified. Import data.int map. I am int map. Okay. I need the set, import qualify data.set as set, import data.set set. Data.map map, import qualified data.map as map. Okay, it's not just not. We're gonna do like the same. Okay, let's just copy this. Let's just move this. Okay, so what is the neighbor's function here? Beep, 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 beep. Okay. Yeah, I'm just gonna brute force this. I don't care actually. Ding, 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 ding. Would I actually use the graph here? I don't actually use. It's just for the neighbors function. So this one, let's have this be word A. So we have a list of A and start in and end. The neighbors function, all it takes is takes an A, and this is something that takes an A and returns a list of A's. Okay. Dun, 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 dun. BFS. Okay. So how do I use this BFS? Do. I already have a neighbors function. Not contained. Okay, now I'm not gonna do this for all of them. The points I'm gonna consider is cause neighbors equals map and so we're gonna do a filter not contain C. Filter not dot contains C of a C. This is gonna be P, so Q points of neighbors of neighbors. Okay. We're gonna do that for the input. We're deleting all of these. We don't care. Ding 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 ding. But we would like to keep these. Actually, these we're gonna use them later. Okay, not all XYZ. We are gonna write here a length as neighbors. And let's just do set that from list, set that to list. Concat map. Cause neighbors. Int, int. Set dot from list. Set that to list. So how many possible neighbors are there? 1631. Let's then use these because okay, so this works to calculate all of them. Now I need to filter which of these are inside and which of these are outside. Okay, and let's write that function. Okay, so let's see. So for this cube, zero comma zero comma zero is outside, right? Oh, let's just make it something else. So is outside equals so it's outside if I can get to is just so P. Okay, so def outside equals definitely outside is -1 comma -1 comma -1. Now is outside P is equal to is just BFS NF import data maybe is just BSFS and then we start at def outside and we end up at P where NF neighbor function is takes in a P see current point cur P and we call neighbors of cur P filter not dot contains C. We don't want to is outside, so this is going to take a while because we're running a lot of breadth first searches. Let's see. Filter is outside. Where outside neighbors equals filter is outside possible neighbors. So let's possible neighbors a surface is exactly that. Int comma int comma int to int. Surface pos neighbors. Surface outside neighbors. Length. Outside neighbors. Surface outside neighbors. Wow, it's taking long even for the sorry. Because it's also like it looks at the it will look at all the points Let's have this 0, so we'll actually not. A def outside 0, 0, 0, 0. Now we're gonna find a path. It's outside. We need to limit our neighbors function here. Filter in range. And then we're gonna need that from before. Next equals minimum. List on minimum by maximum by. Min y max y. Okay, but this is like super dumb, right? So I want to stop as soon as I found another neighbor, right? Pause and a set equals this is just the possible neighbors. Ding 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 ding. We're not gonna do this. The neighbor function is we're just gonna partition the neighbor set into multiple sets and see if there's a path between them, right? But we might not be doing it diagonally. Let me see. Hey, little Lenny. Let's just see how long this in-range thing will do. X is equal to X and okay, it's quite fast for the example at least. All right. We finally did it. So look at these, right? We were doing like 2019 and then 2024 before, 2029 before, right? So there were just a few tricky cases where there were like some tunnels or weird stuff where it would have like a point and would be okay. Anyway, this is yeah, this is also based on the hint, right? Breadth first search. And we could make this faster by making this neighbors function more clever, but anyway, Anyway, it wasn't 7 hours like yesterday, which is... Yes. I'm actually surprised at how fast it finds that there's no path. Maybe like for the ones that are stuck. But for the ones that are outside, it's quite fast. And for the ones that are not outside, it's probably because the sphere isn't so big, right? So we hit the wall very soon. And then, yeah. Anyway, that's it for today. Thanks for tuning in. I would say this was easy. I mean, the task 1 was like, okay, yeah, we did it. And now, yeah, it took us 2 hours to do that. We wish we didn't. Anyway, I was trying to make my approach work. But it was the wrong approach. As Mizard X pointed out. That was exactly the problem, right? I thought like we would be within a sphere and it would just be a sphere, right? But have like a tunnel and then it would technically be outside. Yeah. Anyway, thanks for tuning in. Day 19. We're almost there. We've done quite a lot. Anyway, thanks for tuning in. I hope you enjoyed it.